Dear students, welcome back. Let us begin the third part of the lesson in which you will learn about the additional concepts in ANOVA. In ANOVA, we have an important concept called source of variance. So, this source of variance concept is, so we had a total variance and we are going to divide this total variance in respect to the treatment what we had and what is due to the natural variation. So, because of this source of variation, we are calling this as a analysis of variance instead of analysis of mean. So, ANOVA is all about looking at the sources of variation, that is object of comparison, treatment or intervention or groups. So, we calculate the source of variation using sum of squares. It is similar to the linear regression. So, in linear regression, it establishes the relationship between two quantitative variables x and y. Here in one way ANOVA establish the relationship between one quantitative dependent variable we have represented it as y and the categorical independent variable we have represented it by x. So, here there is only one source of variation, that is your capital X, which is categorical in nature and it is having more than two levels. In regression, the strength of relationship can be quantified by R square. R square is the amount of variation in y which is explained by x. In ANOVA, the amount of variation in y explained by x can also be determined using eta square. So, this eta square is nothing but the ratio of between sum of squares and total sum of squares. So, when we divide the between sum of squares by total sum of squares, we will get a quantity what is called the strength of association. Here for the previous example, we have explained the strength of association is 0.74. It assists the strength of association between the quantitative dependent variable and the categorical independent variable. So, the packages like SPSS gives the strength of relationship as R squared instead of eta square. One important concept in ANOVA is it can be applied only when the treatments are randomly assigned. So, we call this design as completely at random. So, we will understand how to randomize the treatment completely at random. So, once the design is like this, then only we can able to apply one way ANOVA. We will explain the completely at random concept by using an example. So, in the initial module of this one way ANOVA, we have introduced an example on psychodynamic psychotherapy. There the researcher was interested to compare three different psychotherapies called long term psychodynamic psychotherapy, short term psychodynamic psychotherapy and solution focused therapy. So, these three techniques he wanted to compare. Now, we will try to understand how the researcher could have done the randomization of these three treatments on the subject. Assume that you have 15 subjects who are regular patient attending to the psychotherapy clinic and you have three methods to randomize. So, how to do randomization? So, let us for simplicity we will write the LPP as A, SPP as B and SFT as C. So, there are three treatments A, B, C and we are going to randomly allocate to the 15 subjects who are regularly attending to the psychotherapy clinic. So, here I have a sequence of numbers. This list of numbers I have chosen from the hospital records or clinic record, whatever I am having. So, I am just selected the patient and numbered from 1 to 15. So, after this what I am going to do, I will use a random number to select two digit random number. So, I will talk something about a random number. So, random number is a table of numbers ranging from 0 to 9 and from that we can able to choose random numbers. So, nowadays packages or computers are available for selecting the random number. So, assume that these are the 2 digit random number we have taken. So, if there are any repetitions you have to omit that number. So, for example, here the first 2 digit number what I have taken is 84, next 2 digit random number is 18, 9, 37, 93, 64, 95, like this I will keep writing the 2 digit random number. If anything is repeating, you have to leave that number. And then once that 15 2 digit random numbers has been filled out, and you are going to rank that random numbers according to the ascending order. So, the smallest number is 1, so I have ranked it to 1. The next smallest is 9, so I have ranked it to 2. The next smallest number is 14, so I have ranked it to 3. So, likewise you continue ranking from ascending order from smallest number to largest number, and then what we are going to do is we are going to assign the treatment. Since we had 15 subject and we are going to allocate equally among the 15 subject, so each treatment will be allotted to 5 subjects. So, first 5 subject will receive treatment A, the next 5 subject will receive treatment B, and next 5 subject will receive treatment C. So, when you look at in closely, the patient 13th patient will receive treatment A, 4th patient will receive treatment A, 2nd patient will receive treatment A, 7 will receive treatment A. Likewise, you will continue 8, 15, 6, 3 and 10th patient will receive B. Similarly, the other numbers will receive the other treatment. So, this is the randomization of treatment that we can do by using a proper randomization technique that is called completely at random. If the design is performed in this way, then only you can go for a one-way ANOVA. Overall, in this lesson, we have introduced an easier way of performing one-way ANOVA with less mathematical computations using raw score formula. We have also stated the relationship between T and F test statistic and compared the two tests with numerical example. Some additional details of one-way ANOVA, such as the difference between one-way ANOVA and linear regression, strength of association, have also been covered. I hope these concepts would be helpful to you in your research. We have concluded and completed our lesson on raw score formula and comparison of T and F test. We will continue in the next lesson. Thank you.